Good morning, friends. Today we'll be discussing certain topics in solar and wind energy system. Okay, so we are going to see what are the instruments are being used to measure the solar radiation. So we have pyranometer, pyrheliometer, and also we have the sunshine recorder. So these are the two other mains. So we'll be seeing what is the basic principle, and then we will move on to this. So pyranometer is actually used for measuring the global solar radiations. It is which is falling on the horizontal surface. Okay, it is used for measuring the diffused radiation. It's not direct radiation. How we are doing it is with the help of a shading ring. Okay, the shading ring will be preventing the direct radiation to be falling onto the sensors. So this will give you a measurement of these diffused radiations, etc. So this global solar radiations can be calculated by measuring the heat energy, etc. Okay, so this can be of thermopile type. Normally this can be bimetallic pyranometers are also available. So you can see this is an Epeli pyranometer. So this thermopile is an electronic device which is used for converting thermal energy into electrical energy. So you will have the thermopile which will be connected in series. From that, from the EMF measured, we can calculate how amount of solar radiation is being incident. How it is the construction details. We are having two concentric silver screen. The inner ring is coated with black and the outer ring is being coated with white magnesium oxide. So we'll have nearly 50 thermocouples. You know very well thermocouple, one end will be connected to a hot junction, another will be connected to the cold junction. Due to the temperature difference, you will get some EMF. So that concept is being used here. The whole assembly will be in the spherical lamp bulb. Okay, so we have to protect the shield from other environmental conditions. So what will be principles as cited already? The change in temperature between the black surface and the white surface, so that the EMF will be produced. Okay, the EMF will be equal to the amount of solar radiation generated. So this you can see this. You can see you have a glance move, the sensing portion. You will have the black and blue can be in the wedges or disc also. You will have it as. And next one you have a bimetallic pyronograph. It is used for converting a temperature change into the mechanical displacement. Instead of EMF, we are having it as mechanical. When there is what happens temperature. So two materials with different coefficient of expansion they are being taking. And actually on subject to solar radiations, what will happen? One will be the coefficient expansion will be different, so that we'll get a this. Next one, this is actually a diagram. This is which is just to see this. And next one, this radio sensing element also. Bimetallic strips will be fixed in a frame as I showed you, and everything else will be such that there will have no vibrations. Next one is pyrheliometer. This is used for measuring the beam of solar radiations, which is having direct one. Okay. Next one is construction details. We have to measure the solar constant. Okay, it is designed by Angstrom. So a sensitive galvanometer. You will have a thermocouple which will be connected to a sensitive galvanometer. So you can see that it will strip will be connected to an external electrical circuit. That electrical circuit you can measure the EMF. Okay, so both sides strips S1 will be shielded from solar radiations. There will be no deflection. Now what happens? You are exposing one S1 to the solar radiation and S2 is again shielded. So what happens? Due to the difference, we will have certain electricity EMF will be generated. So from that you can measure the strips. If the strips are again in the same temperature, no EMF will be produced. Okay, so the quantity of heat will be depending upon the absorption coefficient of particular strips and how it is. So Q is equal to VI by AA. Okay, so that will be the formula. Actually, so sunshine recorder is also used for recording. So this will be depending on the climatic conditions we are having. So this we have placed in our campus also. Okay, you will have a strip. From that you will have to mark and you will have to calculate. Okay, recording cards will be placed on that, and the sun will be burning. Okay, so this is Campbell-Stokes recorder. This also is used for recording concentrating the sunlight through a glass pier into a recording card. That is the same model only. So length of the burnt trace will be representing the sunshine durations. Okay, so this will be actually you will have overlapping, same principle, but you are having three overlapping pairs of groups will be attached, and you have three different reporting cards based on the whether winter or summer. You will have to, because the solar radiations will be incidenting will be varying, isn't it? So based on that, rotating sunshine recorder, it will be every 30 seconds it will be rotating. Okay, thank you.